Question 11, the pool. The graph on the right represents the aerial view of a pool formed by the rectangle ABCD, A to B to C to D, and the semicircle with diameter BC, semicircle, diameter BC. The distances are expressed in meters. Two posts, represented by E and F, are placed at the midpoints of segments AD and BC, halfway along AD, halfway along BC, respectively, in order to install a net. What is, to the nearest square meter, the area of the pool's floor, given that it is a flat surface? I want to figure out the equation of line E to F, because once I know that equation, then we'll know its slope. We can figure out this slope, and we can use our distance from a point to a line to figure out this distance. Double it would be the length A to D. Also, that's the radius of our semicircle. We're going to need to know the equation of this line. Y equals AX plus B. I want to figure out the A first, which is delta Y over delta X. The delta Y is 28, take away 12. The delta X is 30, take away 18. That gives us 16 divided by 12, divide the top and bottom by 4. That gives us 4/3. Then to figure out the B, I'm going to plug in a point that we know. I'm going to take the 18, 12, replace the Y with 12, replace the X with 18. That gives us 4 times 18 divided by 3 is 6. It's 24. Subtract 24 from both sides. That gives us negative 12 is equal to B. Our equation is now Y is equal to 4/3 X minus 12. I want to find the distance from a point to a line. I'm going to use my distance from a point to a line formula, which is the absolute value of AX minus Y plus B, close the absolute value bracket, divided by the square root of A squared plus 1. This is our equation. Y is equal to 4/3 X minus 12. The A is 4/3, which is 1.3 repeating. The B is negative 12. The X and Y, the X is 28, the Y is 14. We have 1.3, the A, times the X times the 28, minus the Y, minus 14, plus the B, which is negative 12. All over the square root of 1.3 repeating, squared, plus 1. Run that through the calculator, and that gives us 6.8. This length is 6.8 meters. To figure out the area of the semicircle, the radius is 6.8. The area is the area of a circle, pi r squared. Divide that by 2. That gives us pi times 6.8 squared divided by 2, which is 72.6336 meters squared. The length BC is just going to be double 6.8. Is 2 times 6.8, which is 13.6. I'm trying to find the area of the rectangular part of the pool, this little green area here. I found the length of B to C. I need to find the length of E to F, which is the same as the length of A to B. I'm going to use my distance formula, which is the square root of delta X squared plus delta Y squared. We've already figured out delta X and delta Y right here. Delta X is 12, delta Y is 16. 12 squared plus 16 squared, which is 144 plus 256 gives us 400. Take the square root of that. That gives us 20. The length from E to F is 20. The area of this rectangle is length times width, which is 20 times 13.6, which is 272 meters squared. The total area, add that to the 72.6336, is 344.6336 meters squared. And they want it to the nearest square meter. So I'm going to round that. The 6 is going to tell the 4 to round up to a 5. That's 345 meters squared. And that's it for question number 11. Have a good day.